All right, welcome to this session. Today we're gonna talk about serverless, Java, and Quarkus. The title is Make It Funky, create serverless Java apps with Quarkus Funqy. Those slides are also interactive. If you like to follow along, you can go to this link, red.ht/make it funky JDD. And you can follow this slide live. There are some links that we will share. So I would like to hear from you. There's going to be also a poll to make it a little bit more interactive. I cannot access the chat at the moment from the event, but I hope somebody can paste those links in the chat. So let's go forward. Let's see the agenda of today. I'm gonna introduce myself, and then we're gonna talk a little bit about what is serverless and what is Quarkus. A little bit of introduction for those of you not aware of. I would like to get more about serverless and Quarkus, and then we go into the topic of today, which is our Quarkus Funqy, this framework library into Quarkus that enable creating Java application for serverless workloads, and we will see a little demo showing how to do it. We have time then after this session for question and answer. So let's go into this flow. A little bit of introduction of me. My name is Natale Vinto. I'm a developer advocate for OpenShift here in Red Hat. I'm a software engineer with Java background. I worked as a specialist solution architect for OpenShift here in Red Hat. Now I'm developer advocate for OpenShift, which is the enterprise Kubernetes for Red Hat. Love free software. I'm a member of Free Software Foundation Europe, open source, of course, blues and coffee. I hope you already got your espresso. And if you like to, we're publishing with another colleague, with Marcus Eisele, Java champion, a book called Modernizing Enterprise Java. If you like to get this copy in the early release, you can go to this link. And if you like, also, we are on OpenShift TV with a bi-weekly show talking about cloud native architecture. So that is me. This is my Twitter handle if you like to follow me. Let's go into the main topic of today. What is serverless? Well, if you ask me what is serverless, probably this picture gave a wrong impression. So this is an empty data center, right? Well, serverless is not really like that. No, it's a joke. But if we follow the definition of the CNCF Cloud Native Computing Foundation, which is defining a definition about what is serverless in the serverless working group, serverless computing refers to a concept of building and running applications that do not require server management. So it doesn't mean we don't have server like in the picture before. No, it doesn't require in the model that we need to handle this complexity. So we can focus on deploying application as one or more function. We will come back later also in this definition. Before we go, I would like to know from you what's your serverless experience, and I put in the slides these links. So I don't know if we can do it live. Since cannot access the platform chat at the moment, but if you can go into this QR code or go to this URL, which is menti.com, and then you go to this link, you can start voting, and we could see live what's your experience, if you are noob or pro or say good about serverless cloud and Kubernetes in this case. So I'm curious, to be honest, and I would like to know from you. If you go to this URL over here, you should be able to access the poll. And thanks for starting voting. So this help us understanding what is the audience today also, right? So the answer, what is serverless? Just curious, just new to serverless, or serverless in general, but would like to start using it. Somebody of you may use already serverless for some workload, and somebody of you already is writing awesome Java apps, and then we can discuss it a little more about it. So wow, thanks for the vote. Keep voting. We will review the vote at the end of the session. I'm curious about what is the audience today. It looks there's some kind of generic knowledge, and people would like to get more about serverless, which is cool because it goes into our next topic about what is serverless. Let's go on a little bit of explanation about the serverless. So if you look at this diagram, really the serverless pattern is composed of three phases. The first phase is an event that may trigger your application, and this application can also be auto-scaled on demand, and your application can produce a result. So the event that can trigger this can be an HTTP request, like we will see in the demo, but can be also some Kafka messages, image upload, PDF creation, login from a user. This is very consistent to the serverless pattern. And if we go again into the serverless pattern, this is an example. From the browser, you go to some URL. We will see in the demo, we will do something similar. This URL will start a container. This container can also, query a database, do other requests. What about if we have lots of requests? If you think about use cases like for IoT, multiple devices connect at the same time, we would like to scale it a lot. And in the serverless pattern, this is something that is possible. And when you don't invoke the application, your container is not executed. So this means that we are saving also resources. We did the sample for the HTTP request, but really can be also a Kafka message or a Kafka stream, triggering our application, our function, and going into some storage, some database. The benefit from this model is that we don't need to set up any auto-scaling, load balancer. The application is scaled down automatically. If you don't use it, where it's not consuming resources, and it's scaled up on demand. We will see also in the demo that we can also track revision. If we have multiple versions of our application, we want to do our A/B testing, we can track those and we can start those only when we need it. So this is really cool when we talk about resource consumption. In fact, one of the benefit of adopting the serverless approach is that usually you tend to study your consumption, and you could over provision or under provision because you don't know before. With serverless, you are really shaping on demand. So you are serving the traffic, you're serving the capacity only when needed. It can scale it up a lot, but it can stay idle if nothing happened. And we will see how, and I also would like to discuss more about this model with you. Before going into the main topic of today, some trends. So 40% of enterprises say adopted already serverless. 60% would like to reduce operational cost. Everyone is looking for removing any vendor lock-in. And the biggest concern with adopting serverless is this one: how to avoid the vendor lock-in. Because serverless is very popular across public clouds, but how we can have something that is agnostic and consistent everywhere. Well, one of the answers is also doing serverless the open source way. There are some open source serverless projects which are agnostic. Being Kubernetes today the de facto standard for container orchestration, and most of the time is our target platform. We mostly would like to run our application on Kubernetes. Kubernetes serverless is called Knative. And Knative is a project that allow you to write serverless application on top of Kubernetes. The cool thing is that you don't care where, can be public cloud, private cloud, hybrid cloud, whatever, can run everywhere. So you just need Kubernetes and Knative, and you write your function, and we will see in the demo how we can deploy such function at ease. Modern serverless application. So how to build modern container-based cloud-native Java serverless apps. We understood most of the time Kubernetes is our target platform. Kubernetes execute container image containers. How we can start writing our Java apps? Well, I would like to talk to you about also Quarkus. Quarkus is a Java framework called subatomic Java framework because it's able to supersonic, subatomic, because it's able to run on a minimal footprint, and it's optimized for cloud native workloads such as on Kubernetes. And let's have an overview of Quarkus if you don't heard about it, if you heard about it. This is a Java framework which is Kubernetes native. This means that it's designed to run also in cloud native environment. It's designed to work with microservices, and it's designed to be serverless and event driven. In fact, it works perfectly on Kubernetes, Istio for service mesh, and Knative for the serverless part. Historically, the enterprise Java stack was like this. No, we have our monolith and we have our framework, application server, Java virtual machine, operating system, and some hardware. Today is different. Today there's Kubernetes at the bottom of our application. So our container is running, our app is running into a container as a microservice, and it's mostly running on Kubernetes and Linux. Quarkus is optimizing this space, optimizing the Java stack, because there are some optimization to reduce the memory footprint, the startup time. We will see a little bit how we can work on it. And serverless is one of the use cases when using Quarkus. That's why there's also an extension in Quarkus that we will see in a moment called Quarkus Funqy. If we go, there's this poll, it's not very updated, it's 2018, but this poll say, in 2018, say 6% of Java developers are using serverless, and the other languages comes along, but this is going increasing and growing because there's more support for Java framework in serverless workloads. We have seen an overview of Quarkus. The name, if you are curious of Quarkus, Quarkus comes from the quark elementary participle, and you us are hardest thing in computer science, which is us. No, it's a combination of these two terms. And the cool thing of Quarkus is that comes from the experience from many projects. If you are aware of JBots or Wildfly and Undertow and OpenJDK, and MicroProfile, REST-Easy, Hibernate, Vertex. They are going into Quarkus, and the differentiator, as we mentioned, is a container first. It joined the imperative and reactive, and as we see, it support also serverless workload. The cool thing for serverless is that we can, when the application starts in serverless, we need that they start very fast, no? Because if it is not executing, when it's not invoked, when we invoke it very, very fast. So Quarkus has some optimization for Java, but also if we need the most fast application in the world, we can compile it natively because Quarkus support GraalVM. We will talk in a moment. And it's very cool for developing in Quarkus because you don't need to restart the application, compile all the time. It's gonna do it automatically. We will see in the demo. There's also an option called continuous testing, where you continuously test your application. The other benefit, as we mentioned, mixing the imperative and the reactive. If you would like to also use this paradigm. We talk about the ecosystem. There's lots of integration. We will see today in the demo Kubernetes, OpenShift, and the numbers are really cool. In fact, we will see in the demo how to start a serverless application in Java and in native compiled Quarkus app. Those are some numbers of the footprint of the memory at the startup time. All the details are on the Quarkus website if you're curious to discover more. So after this, we can decide to go into Red Pill and use native Quarkus compilation on GraalVM or JDK. It's up to us. Or of course, some optimization for the GraalVM native image. We will see how it could be made automatically in Quarkus Funqy. And so we have the chance to select a runnable Java apps and or a native app. The Quarkus ecosystem is composed by many extensions. Today, we're going to talk about Quarkus Funqy. It's one of the extensions enabling serverless workload. Quarkus Funqy is part of the Quarkus serverless strategy, which aim to provide a portable Java API, which is can let you write function in an agnostic way. You can use any function as a service like AWS Lambda, Azure Function, like in public cloud, or Knative and Knative Events. We will see in the demo how to be agnostic and run in any Kubernetes. So this is kind of abstraction that keep you writing Java code that can run in many serverless platform. And moreover, it can let you be very powerful and agnostic when using with Kubernetes and Knative. And we will see in a moment. The function as a service in Kubernetes, we will see in the demo in a few seconds, is something like that. This complexity is masked, but you work with microservices containers under the hood, but you write function. If we will see what does it mean right now. No, those functions can have multiple revisions, so you can have multiple versions of the function, and the Kubernetes itself and Knative is in charge of splitting the traffic, controlling the traffic in this way. How do you react to event? Can be HTTP call, can be Kafka messages, Slack messages, Telegram, Twitter. Those are what is called cloud events. Those are a specification in the serverless world when you have some event, and those events are cloud events. Knative support those cloud events, and the function as a service implementation in Knative, what we will see in a moment, is supporting also this one. So this is the overall, let's say, flow of a serverless application. We will see in the demo how can we do. We can start from the source code and integrate the Quarkus Funqy as an extension, or we can use the KN CLI that help us bootstrapping Quarkus application. So now it's time for the demo. We talked about more about the integration. Let's go into the demo. Let's make it funky. As James Brown, this is a quote from James Brown, let's say, the first part of our demo is going into this website. Because when we go into this website and you have the link in the slides, you go to the, let's say, a configurator or Quarkus where we can define our application. So for instance, let me increase the font so you can see everything. So I want to start writing my Java serverless app. No, let's say Comrade that and the group and the artifact is hello JDD. Let's make it a Maven one. So what we need now is we need the Funqy extension, and it's here. If, as you see here, you can also select Funqy for some public cloud serverless implementation if you are using some specific one. I'm using this is kind of generic, just HTTP binding, but you can use Knative Event, Google Cloud, AWS Lambda if you like to. So I'm going to use this, and then I would like also to use the Kubernetes extension because I let you Quarkus create some Kubernetes manifest for me, and also would like to use Jib to create the container image automatically without any Docker configuration. So this is pure Java, no? Let's say it's pure Java. Let's download the zip file, hello JDD, and let's start coding. I think I have it already. Let me move it from my path, which is this one, and hello JDD, and let me move it here. Let me extract here, and I hope you can all see. So I downloaded my zip file, and I have my structure. Let me open my editor. In my case, Visual Studio Code can be IntelliJ, can be whatever you like to use. If Visual Studio start, hello Visual Studio. Visual Studio has some issue. Oh, that's interesting. Come on, Visual Studio. Visual Studio is having some problem. Let me try to open the folder. Probably, or let me try to open just Visual Studio like from here. Okay, okay, let me try this way, open a folder, and let me try in this way. All right, should be good. No. Visual Studio today has some problem. Okay, let me try again, otherwise we go into another way. It looks, it's starting. Okay, fantastic. Yeah, some Visual Studio had some problem for some reason, we don't know. Okay, now let's go here. Let's wait that everything start. And we generated some code here, no? There's something auto-generated. Let's wait that Visual Studio start all this stuff. This is an example on how to use Quarkus Funqy. Quarkus Funqy is an extension that lets you work, in this case, with HTTP requests. When you use the annotation func, this is going to be post or get. You can use Pojo or Java beans here to populate it. For instance, we can just refactor this and call it, let's call it JDD attendee. And let's call it JDD attendee, and we call it attendee, and we call it. Of course, we fix this, okay, and we call it JDD attendee. Okay, so we did our change. No, the first thing we can do with Quarkus in general, it's we can do maven compile. Quarkus dev. This means, and we make sure that if we do some change here, we also change our test, of course, because there are some tests already written. So JDD attendee, and the friend, it's a hello friend. So everything should be fine. When we go into this methodology, this is the dev mode in Quarkus. We can do our change without rebuilding or restarting our application. And it goes also into continuous testing mode. So if we add any test, if we change the test, we can resume or restart the test. In this way, we are basically trying the application locally. No, if we go here, and this is my application. So if I go to get, I don't get the result, but let me try with curl doing a post, and I'm gonna open a new bash here. So I'm gonna do the curl and giving with a post request the name Bill and say hello Bill. So really an example on, so this is locally. Now I want to make it serverless. And want to deploy on Kubernetes. In this case, it's an OpenShift cluster. How to do it? The first thing we need to do is, first we need to create the container. Right now, we just deployed locally Quarkus. We need to create this container. And for doing that, we need to do this thing. We need to instruct Quarkus on how to do it. So here, for instance, say, I want to go to Docker app, not to push my container to Docker app. I want to use Jib as a library. I want to use Knative as a target for my Kubernetes manifest. So this is the thing I need to do for my stuff. The other thing I need to do is also logging in Docker because in Docker Hub in this case because I need to deploy this stuff. So let me go here and say Docker login Docker IO. I want to push to Docker IO. If you are, I'm already logged in. Otherwise, it's gonna ask for password. Jib is gonna write my credential, and from my credential, it's gonna start doing the compilation. So we are almost there. Once we are logged in, let me check because I would like also to open my application. So this one, save it. All right. So I want to start compiling it. The first thing I need to do is Maven. Maven package, Maven clean package. So let's do it. When we do this, what happens? We're gonna create the artifact. We're gonna create the container image with Jib. So we don't need Docker in our machine in this case, just because we decided to do that. If we want to use Docker, you can just refer Docker in the property file. And this is gonna be at the end of all of everything. It's gonna be pushed on Docker app because we, by default, we're pointing to that system. So after the tests are run and everything is fine, we should see our application pushed on Docker Hub. And then there are some Kubernetes manifests that will be automatically created for us. Those are in SRC main Kubernetes. While this goes, we can explore it. If you see from the output, the container image has been created automatically and pushed to Bluesman.io hello JDD snapshot. In fact, if we go to Docker Hub and if we go here, you can see a few seconds ago, this tag has been pushed, which is the 100 snapshot. So we created the container image. Now, the next step is to deploy to Kubernetes. I'm connected to this Kubernetes cluster, which is an OpenShift cluster. And I wanted to deploy the Knative service in this case, created with Quarkus Funqy. Easy. We go in this command, create target Kubernetes Knative, so we can also review target Kubernetes Knative JSON. You see those are settings that have been created automatically by Jib, a Knative service. And if we go to the topology here, a new application has been created. This application is reachable from outside. And if we try to invoke it like we did before, no. If we try to invoke it in this way, no. Right now it's exposed on internet. So let me invoke it on internet. Hello, Bill. And you can change. You can try also yourself. So my application is started on Kubernetes, and this is a serverless application. This means when we don't invoke it anymore, this is going down. Scaling down. When we invoke it a lot, this is going to be scaled up a lot. So it can be a number that we can decide, let's say from 2 for 10. It's a tag, is a label, a notation we can use, but we can decide how much we want to auto scale this application. By default, after 5 minutes, it's going to go down. And so we can see that. So we can go in the other, we can go in the other demo because in fact we have 2 ways to deploy the code with Funqy. One is this one, and the other one is going into using a CLI which is called KN. This KN CLI as a subcommand called, in this case, called Funq. And this is useful to create a skeleton of our application that can be used to deploy the function as we did, but in this case from a CLI. And we can do in a native way, so we can see the Quarkus native compilation. So let's do it again. Let's see if we can do it again with this CLI in this case. Let me open the CLI here so I can show you in another place how to do. I will go here and go here and rename this to another name because that was a crash in Visual Studio Code. Okay, so let's work here. We want to create right now a skeleton of our app with the KN function. Let's do it. So let's do like this. KN function create. KN function create can create for us the function. We can do from here. Let me do also from here. Can func create hello JDD. So I can demo to you the revision part in serverless application. When you use KN func, this is the CLI for Knative. Func is a subcommand that can create function as a service function. You can decide which is the runtime. In our case, this is the Quarkus runtime. So let's go here and let's see what has been created. In this case, there is this this file where we can that we can use to instruct Knative func to create a Quarkus application. In this case, we want a native application. We want some native app, so it's gonna start very, very fast. Very easy to do it with the KN. So in this case, we didn't created the skeleton with Quarkus code builder. We just created this one from the CLI. Another example on how to use Quarkus Funqy. You use the annotation, and you can use the bin to have some HTTP message parsing. In this case, those are two bin input and output. When we want to deploy it, just this command func deploy kn func deploy, and this is gonna also build the container image. In fact, if you do function func build, you have to enter where you want to push your application. Let's push it to our Docker app in this case. I'm also logged in. If you remember, I did the Docker login. The name is going to be hello JDD. So yeah, so this is going to be Docker IO Bluesman. Yo, this is the group. Okay. And this will start to build the image. So this is a native compilation. It's take a while. It gives me the chance also to show you that our serverless application now is not running because we are not invoking it. For the purpose of the demo, let's say we already built this native application because it's going to take some minutes. We can deploy and skip the build if we already did it and push it, and I did it before. The build false. This is going to push to the registry, and our application is deployed to the same Kubernetes namespace. In this case, the same URL, if you see here. Going back to the topology, this is our new application. If you see, it's deployed here. This gave me also the chance to show you another cool thing, that we are creating another application with another behavior. The behavior in this case is not fun, but it's function, the name of the function we want to invoke. And if we want to invoke it, we can do our curl. In this case, we are sending a message. The message is Quarkus rocks. So the application is responding. If we invoke lots of time, this is gonna be scale. This can scale it up. It depends on the load. Now the load was not so much, but we can stress this application. And I wanted to show that this is scaling up. And also I wanted to show that this is another revision of the application. So I'm deploying another version of the application on another tag, which is the one our build could deploy and send it here. You see the native compilation is really, the size of the image is really small, 30 megabytes for a native compiled application. I can invoke it in a serverless way, and I can show you that you can track also the revision for your serverless app. If you go here, you can see the revision. So the first one was some minutes ago from the code Quarkus.io. Then we did the second with the Knative CLI with the function, and we deployed on the same project multiple versions. And now the traffic is routing to this revision. When you don't use it, it's not invoked. When you use it the first time, it's going to be start. And you see the auto scaling is so fast with the native compilation, which is really, really straightforward. Sometimes you don't even have the time to reload the app. So this was the example for today. I think we are going also into the end. I wanted to give you this overview of how to make Quarkus application with and automate Java serverless performant application for the cloud and on Kubernetes. First methodology, you can go to code Quarkus.io and you can do create the demo, the software as from here. The second methodology is you can use, if you are connected to a Kubernetes cluster with Knative, you download a KN CLI, you run this command, kn func create Quarkus, it create that skeleton. You can log into your Docker app or Quay.io and let this tool compile, create a container for you, and then use the function to deploy. So we have seen two strategies. In the first one, we created the Kubernetes manifest. In the second one, this is hidden, but it's another strategy to deploy serverless application. We're getting into the end. For the last time, I would like to leave you with some resources. You have it in the slide, in the link. So if you want to learn more about Quarkus Funqy, you go into this link. This is the official documentation of Quarkus Funqy. Please sign up to developersredhat.com to find out more about OpenShift and serverless and Kubernetes, Knative. You can download for free this cookbook, the Knative cookbooks, to learn how to run and write serverless application on Kubernetes with Knative. And also, you can try serverless your own in our learning portal. You just need the browser open. It's going to start an environment that you can start working on OpenShift as we did today together. And last but not least, if you're interested in getting more about Knative, Quarkus Funqy, we do a Knative serverless deep dive of the Red Hat Developer Dev Nation. It's a 1 hour workshop, free workshop that we run in a series. So please join us and subscribe to get more. With this, I think we are at the end of our 45 minutes. I would like to thank you for attending this session, and I'm available, of course, now for any question that you may have. So thank you.